Hello, welcome to De Gruyter's Book Talk. My name is Dr. Christene Smith, and I'm an acquisitions editor with De Gruyter. Today on our book talk, I'd like to introduce Dr. Phil DeLuna, our guest and editor of an upcoming book on accelerated materials discovery. Nice to have you today, Phil.
Thank you for having me. It's a pleasure to be here, virtually, of course.
Virtually, of course. Before we dive into things, I'm just going to give a brief bio for Phil for our listeners so that you can get to know him and his work. So Phil currently serves at the National Research Council of Canada. He's the youngest ever director, where he built and led a $57 million collaborative research program on Canada-made clean energy technology, which is a bit about what we're going to hear about later, but not totally. His main goal is to develop transformative technologies to help Canada achieve net zero emissions by 2050. He's a Governor General Gold Medal winning scientist, a member of the Royal Society of Canada, and recently announced as adjunct professor at the Department of Material Science and Engineering at the University of Toronto. He has many, many awards and prizes. I won't go into them all because I would be here all day. But importantly, I think it was in 2019, he was announced as one of Forbes' top 30 under 30. And he recently edited a book for De Gruyter. So welcome, Phil.
Thank you.
Yeah. So we're just going to dive in and talk a bit about your book, set to come out in March. On accelerated materials discovery, how to use artificial intelligence to speed up development. This has been an ongoing project, I guess, for over a year now. Maybe from your words, why don't you tell us a bit about what the book's about? We'll take it from there.
Sure. So the book is really about how we can use new technologies, digital technologies like artificial intelligence and robotics to help speed up discovery and specifically materials development. And this is really important for a few reasons, but the number one being I work in clean technology and clean tech, and addressing climate change is my biggest passion. It typically takes around 30 to 40 to 50 years to go from an invention to the market, and we don't have that time. We need to speed up that cycle to go from invention to the market. And today, thankfully, we have lots of tools that we can do that, like artificial intelligence, which will help us speed up the processing and data analysis and find complex correlations in data that we normally couldn't be able to find. Or robotics that helps us to automate much of the actual synthesis of materials and the characterization of them in ways that are more reproducible and consistent. So this textbook is really about how do we develop the next generation of material scientists and chemists and engineers, and how can we merge this exciting and new world of artificial intelligence and robotics with the traditional time-tested and true artisanal world of materials and chemistry.
Yeah. No, I'm really excited for its release. I think it's the kind of book that both students and researchers alike would have a lot of use for. I think when I think about why now for emerging AI and materials discovery, I really drove something from your preface for the book, which is that computational power has exploded and data is everywhere, and robots are much better than ever before. How do you think these three concepts tie into the topics and the researchers that you decided to include into the book?
Yeah, no, that's a great question. And it's absolutely true. I mean, take, for example, your cell phone. You have more computing power in your cell phone in the palm of your hand than existed that brought man to the moon. And so with digital technologies, whether it's artificial intelligence, robotics, AI, all these sorts of things have been really pervasive in all other different kinds of sectors, whether it's business or consumer goods or medicine, et cetera. So it was only a matter of time before it also impacted science and the way that we do chemistry and material science and discovery. And so the way that we can break down this book into different chapters are the ways that you can use artificial intelligence or robotics to help speed up discovery. And there are different kind of levels. So the first is just using computational simulation and artificial intelligence to help speed up how you simulate new materials. And the example that we use in this book is how do you model catalysis or new materials to convert, like for example, CO2 into fuels and chemicals. Then the next step of that is beyond just the modeling, how can we also incorporate spectroscopy or materials characterization? When you measure a material and you, for example, shoot X-rays at it, you get a lot of rich information from that. So much information that you actually aren't able to process that using just your mind. And that's why there's lots of modeling to do that. But there's a lot of information there that could also be processed with artificial intelligence. And then the next step to that, so we've already done the modeling, then we looked at the characterization. Well, can we actually automate making materials themselves? Yeah. And that's the concept of self-driving labs, which is another chapter in the book. And then finally, it's the algorithms that feed into those things and then how it's being used in industry. And so we have some amazing authors and researchers from Toyota Research Institute and Citrine Informatics and the University of British Columbia and Harvard and University of Calgary and the National Research Council, just some incredible world leaders in their field who are doing some really exciting research and publishing in the best journals. And I was just so excited to be able to collect their insights and their thoughts. And every single chapter in and of itself could be a mini book. And
yeah, absolutely.
It's just really, really exciting.
Yeah, I also really appreciated that all of the researchers that you chose to include, like, they're not only coming from one sector of industry or academia, like it's everything all together. And also national research labs, of course. And I think that's really, really important now. A lot of times academia and industry seem to silo separately from each other. They don't really talk the same talk, and having them all together in one project is really great. I think there should be more collaborations like that.
I couldn't agree with you more. And I find that the problems that we're faced to solve or forced to solve are becoming more complex and more wicked, that you can't actually approach it from a siloed approach. People always talk about multidisciplinarity, and it's become like a catchphrase in a word, but there's a truth to that. And it's not only multidisciplinarity in terms of discipline, but it's also diversity in terms of perspective. Industry, academia, government labs, nonprofit spaces, all of these things need to work together in order to solve problems now. Yeah,
absolutely. And for background, I was trained as a materials scientist, but I don't have any idea about AI and how to use it in my research. And so having books like this that allow for that bridge between industries also is super key and super exciting. Cool. So I think we've talked a lot about, the book itself, the deep topics that maybe the average audience might not be able to relate to so much. But part of your work also is doing, a lot of outreach and bridging the gap between the researchers and the general public. Maybe could you tell me a bit about how you do that in your work?
Yeah, I think communication is actually I think my superpower. I don't think I'm the smartest person. I'm sure there's many more smarter people who will win many more Nobel Prizes than I will. I'm certainly, the kind of person who believes that the way to make impact is by sharing the work that you do in a relatable and digestible way with as many people as possible. And so I do that in many different ways, whether it's, I always try to give talks to general audiences. Just last night, I gave a talk at King's University as part of a distinguished lectureship series. And then I try to write in op-eds and blogs. I vlog every once in a while, and I host a podcast too. And so the podcast that I host, it's called What's Next In, with my co-host Liora. She's incredible. Her background is in psychology and in design thinking, and my background is obviously in science and research. And so coming together we really just have conversations about topics of trends that we see that's coming down the pipeline. It's called What's Next In. And that's another way that I like to disseminate the work that I do.
Yeah, and I heard that recently you recorded such a podcast actually about what's next in automating scientific discovery. So, without further ado, I'd like to thank Phil for joining me quickly about the book, and to invite the listeners to keep tuning in, and we'll hear that conversation between Phil and Liora on automating scientific discovery. And yeah.
Phil, I heard rumblings that you are editing a textbook. Is that true?
Yes, that's right. That's right. I am editing a textbook. It's called Accelerated Materials Discovery, and it is coming out in March.
That sounds like a bestseller.
You better
Okay,
believe
it. Very fancy title. Tell me a little bit about what that actually means.
So the idea of accelerated materials discovery is, you know me, I'm a scientist. And science is done pretty empirically, trial and error. You go into a lab, you make something, you test it out. It's kind of like baking. And eventually you do this over and over again, and then you get the right recipe with the right conditions to make the tastiest cake. But we can do so much better than that, especially now that we have more data, more computing power, and cheaper robotics. The idea is, can we try to automate parts of the discovery cycle, automate parts of science to try and make that discovery loop faster so we can get to better discoveries and better materials and, save the world quicker.
Automating science. That's fascinating, because I find oftentimes if you're not really in the science world, the idea of automation often comes around, tech. How can we, automate software? How can we get things to work a little faster? But when we think about science, at least for those who are outside of the science field, we don't often think about automating experiments. Give me an example of what's a typical, this is a very broad question, but give me an example of what an automating experiment could look like in terms of benefits and even just timing. What does that mean to automate an experiment?
Sure. So let's take a moment and think about how long it takes to take a discovery out of the lab and into the marketplace. I'll give you an example. The car was first invented in the late 1800s, and it took about 70 years for it to get widespread in society. The electric vehicle took far less time for that to happen because, it something already existed.
Right.
But when you're trying to do something like, for example, make a new battery for an electric vehicle, you have to go through different steps. They're called technology readiness levels.
Right.
You start at the lab, and then you build a little prototype, and then you take that prototype and you put it into a battery pack. Then you take the battery pack and you put it into a car, and then you figure all these sorts of things out, and then you build a car and then you sell it. And then you have to do that over and over again. And every step along the technology readiness level is an extra zero to the cost. It's exponential. So what would cost you, a few $100s to build a tiny battery about this size, for you to do the research and development to scale it up will cost millions, if not tens or hundreds of millions by the time it hits the market. And that's kind of what happens with Tesla.
Right.
Now, the idea of accelerated materials discovery or an experiment that you would do, for example, let's take the battery. A battery, you have an anode, you have a cathode, you have an electrolyte, and then you have a charge that goes from one side of the battery to the other side of the battery, depending on whether or not there's a circuit. There are materials that make a battery. Lithium ion, you hear that all the time. Well, you can think of, there are many ways to arrange or make a lithium ion battery, different carbon materials or different ways you can dope that lithium ion battery to get different performances. In fact, the search space for this is massive. And the way that traditional discovery works is you try something in the lab, you've tested, you would mess around with it a bit, you see if something else works, and if it doesn't, you keep going, and you an entire field emerges and everyone is trying and playing around. The idea of accelerated materials discovery is, what if we can automate that search process? What if instead, what if instead of just going into the lab, building something, you have a robot that takes a material, makes it, uses that data, processes it using artificial intelligence, and then comes up with the next iteration of that material to make. And the promise is that you could save, instead of taking 20 years and $20 million, to find the next clean energy battery, you could do it in 2 years and 2 million. So that's the promise.
Sounds fantastic. I mean, that sounds a lot better in terms of numbers. I guess one of the questions that comes to mind, and this is often the biggest question, is, okay, so then what does the scientist do, right? So we see this question every time we think about automation. And oftentimes there's almost like misconception that, well, we don't need the worker then, but that's actually not true. But I'd like to hear your thoughts on what does the scientist do when we start to automate experiments?
It's a good point. And, if you think about what is automation, automation is coming after the factory worker, the cashier, the truck driver. Soon it's coming after accountants and lawyers.
Gonna get you.
They'll get you, right? And eventually it seems like more and more it might be coming after scientists too. But the idea of discovery, it's a very by chance thing. And the point of automating discovery and using robotics and artificial intelligence to help speed up that loop is that it's just an additional tool, because there's so many combinations of things and there's so much that's happening that a scientist can't do it all in a day or read every paper or do all these sorts of things. They need help. And as more time continues and there's more scientists, it's just exponential. So I don't actually think that we'll be getting rid of scientists, but rather that by automating parts of discovery, we can help scientists be more effective so they can focus on the why and the how rather than the what of doing this thing over and over and over again.
Which is so powerful. And that's kind of what we're trying to get to with the idea of, focusing more on knowledge workers and not just, perhaps some of the repetitive wet lab stuff. It's interesting because, if you think about how many papers are released every day, every month, every year, there is so much data coming out of so many niches of fields, right? There's so much data out there. And there's no way that even if you are in a specific niche, you can know every single piece of data and paper going around the world. I feel like automation will actually help to be able to actually make better experiments, go through these faster, go through those trial and errors, allowing folks who are kind of, the knowledge piece of scientists to actually take a step back and think about what's that broader piece that we want to go to.
For sure. Actually, there's some research that was done out of UC Berkeley where they used natural language processing and artificial intelligence technique to scan through papers that have been published, just their abstracts and publicly available stuff on Google, scraped like hundreds of thousands of these papers, and then built models to see if they could predict materials, how they're developed, all these sorts of things, and kind of find trends, like what is going to be the next big thing. And I think that's like very meta, and also, when people think of discovery, it's almost a romantic and artistic thing, right? Like there's an art to science, but I also think that there's a whole lot of data too, and there's almost a side of scientists that will think, they'll be skeptical of these conclusions, skeptical of this automation, skeptical of what a simulation or a model can provide, and that's totally fair. So there's also a culture war at the same time, and I think that's true in every field that's experiencing artificial intelligence or automation right now. What do you think?
That's exactly it. It's funny when we think about automation, like we mentioned, when we use tools like AI to start doing things that traditionally was a lot of the essence of some of these roles, right? So if we think about science, it's just one example where a lot of the role oftentimes is, going through papers, figuring out, ideas or like elements of what your next experiment could look like. What are those key things to point at? But when that kind of key element of what we traditionally might think of as a role as part of being a scientist is automated and we kind of start to take a step back, there's this element of trust that has to happen. I mean, science is just what we're talking about, but this is across any field. There's this element of trust where we have to take a step back and say, what, we're going to give this technology a shot and we're actually going to take a step back and see what it gives us and use it as a tool to like jumpstart what we want to do, as opposed to being skeptical and, being a bit of a laggard around it. And I'm assuming, or maybe this is not right, but it's going to be generational, right? Like I feel like some of the younger folks are going to be more apt to use it right from the get-go, whereas folks who've been in the industry a bit longer might be a bit more hesitant.
Yeah, no, I think you really touched on something, which is trust for automated solutions or trust for AI and robotics in that space. And I'll give you an example, sort of, a mind hypothetical situation that I want you to think about. If you knew that the COVID-19 vaccine was actually developed by a robot in a lab with minimal scientific or human input, would you feel comfortable taking it?
Ooh, good question. I feel like I might. I don't know. And I think this comes down to just people's level of understanding and comfortableness, is that a word? Like being comfortable with like tech solutions. I feel like, growing up and just kind of being exposed to different AI solutions, not really understanding, but like the underlying concept of what AI is really trying to do and this pattern recognition. I feel like that is almost part of what makes you comfortable when you start to really understand what's going on behind the scenes. I feel like the more foreign you are from these concepts, the more mystical it might seem, the more it's like, this is magical. I'm not really sure what's coming out. But I feel like once you kind of start to, I'm going to use understand, I'm not an AI expert whatsoever. But once you kind of understand like what it really means, what AI does in machine learning, and the idea that it's just trying to find optimal solutions based on, pattern recognition and algorithms, then it's like, okay, well, people could have done that, but they're doing it more efficiently and with machines. It's my long-winded answer of, I think I'd do it.
That's awesome. I think it really depends on what the risk tolerance for some people are, right? Like there's some people who are already driving around in self-driving cars in Tesla or Waymo in the States and they're loving it, right? And there's some people who would never, ever give up that right. And I think it's interesting because you'll never get 100% adoption of anything. I think the vaccines have actually showed us that. But it does make me wonder, will we have this sort of bifurcation in society where you have some folks who are embracing these tools and these technologies to help accelerate or automate parts of, their work, and those who don't? And what will that mean for solutions, whether they're trusted or not?
And another thing to think about just in terms of like these thought experiments is a lot of the stuff that our day to day were initially not automated and now are, and we don't second guess it. Yeah. And it's almost like, how does this kind of historically come and to be part of our day to day, our society? There's so many things that we just take for granted that used to be quite manual, but are now automated. And when we think about these technologies or these solutions that are being automated and we're so nervous about it, oftentimes that could be a sign of like, that's kind of the next thing that's going to be automated in just a few years, right? There's the initial, if you think about, a product life cycle, there's that initial like skepticism, then there's that adoption, and then that kind of becomes like our day to day. So I almost envision these as like, where are we on the curve of, overall society being open to it or not?
Do you think there's a limit to automation? Do you think there are things that AI, robotics, and that it just can't do?
Absolutely. I feel like, again, context, right? I feel like I could give an example now, and then maybe in 10 years when we're doing our 100th season of What's Next, we're going to look back and be like, that was funny. We're laughing about it. But I think it's like, it's society, it's context. It's things that, seem a little bit crazy now, but again, in a few years, this probably won't be. So I feel like I'm sure there's things that are like, I wouldn't automate that. And then, technology is moving at such a pace that I'm sure whatever I'll say in a few years will be like, we automated that. It's no big.
So what do you think is next what's next in automating scientific discovery? I think, for the textbook actually outlines that it's still a very nascent and early field. And I think a lot of people don't even realize that you can, try to automate parts of science. What do you think, if this starts becoming more mainstream, how do you think people react to it?
I think it's important to almost take science and compare it to other industries too. Again, as someone who's outside of a science background, I think that it's just another field that's being automated. We sometimes take science as this whole industry that's just, we can't automate that. It has to be done by the books. How we've always done it is how we've always done our discoveries. But that's not the case. It's just like every other industry that's going through a time that's going to be, revolutionizing how we're doing things. And it's, it's not an outlier to anything else that's going on in the world, right? So, yeah, like I think it's important to start automating it to, accelerate a lot of the things that we're doing. Especially because I read a fact. I don't know if this is true or not, but I was reading an article where, like, there's millions and millions of pieces of data in one field that are being released, but one person can only read, let's say, 250 papers on it. And so there's almost no other way. Like we have to start automating given how much data is coming out. So that's where I'm at.
Yeah. I couldn't agree with you more. And, having published lots of papers and seeing like scientific literature, it can be overwhelming. Typically what you do is you go on Google Scholar and you Google, whatever topic. And in a way, AI is already working because depending on what results it gives you in the Google Scholar search, I'm sure there's an algorithm that is pointing you towards some research more than others, whether it's citation counts, whether it's number of views and clicks, whether it's the journal that it's published in. And we don't even, as you said, we don't even realize it. So I think science, you can't run away from automation in a sense, or artificial intelligence impacting science in that meta way. Yeah. I think that in the short term, there's going to be skeptics and there's going to be sort of like a culture war in that sense, and people who will say and cling to the role of the scientist, which I think in many aspects, and like the more sort of theoretical that you get, the more high level and abstract, you really can't automate that stuff. Right. But I do think that these like accelerating the discovery in general will just be another tool that scientists and engineers and whatever can use to help them get to the answer quicker, or a answer. It may not be the right one, but I think that's part of our motto that throughout this entire thing is we're both people that think we should fail fast and learn from it, and right. This is a way to do it.
I love it. And I'm excited to see what the world of automating science gets us to next.
And that's Phil and Liora's conversation on what's next in automating scientific discovery. Again, I'm Dr. Christene Smith for De Gruyter. Phil's book, Accelerating Materials Discovery, comes out this March 2022. You can purchase it in electronic form and physical form from De Gruyter's website, degruyter.com. And with that, I'd like to thank you all for your attention and see you next time. Bye.